Welcome to the tutorial for operating systems. So we will cover these points through this video: synchronization hardware and Mutex locks. So let's look on to the topic synchronization hardware. Software-based solutions such as Peterson's are not guaranteed to work on modern computer architectures. So we have to use another method. We explore several more solutions to the critical section problem using techniques ranging from hardware to software-based APIs available to both kernel developers and application programmers. For the critical section problem, we use a simple tool. It is known as a lock. Locking. It is the process of protecting the critical regions through the use of locks. So for this process to be done, a process must acquire a lock before entering a critical section. To exit the critical section, the lock must be released. Hardware features can make any programming task easier and improve system efficiency. So we can look on to the next slide. Test and set instruction. We use special instructions to solve the critical section problem in a relative simple manner. So this is a test and set is an instruction. We use many instructions here. This instruction is used to abstract the main concepts. This is the definition of test and set instruction. So we can look on to this. Boolean test and set, Boolean start target, open the bracket, Boolean RV equal to start target equal to true, return RV, close the curly bracket. This is the mutual exclusion implementation with test and set. So let's look on to that. Do open the curly bracket while test and set and lock equal to false while it is true. As I said, we use these special instructions to solve the critical section problem in a relative simple manner. We use test and set and compare and swap instructions here. These are the two instructions used here. These are used to abstract the main concepts behind this. So let's look on to the test and set definition. The important characteristics of this instruction is that it is executed atomically. So if two test and set instructions are executed simultaneously, they will be executed sequentially in some arbitrary order. If the machine supports the test and set instruction, then we can implement mutual exclusion by declaring a Boolean variable lock initialized to false. Okay, this is the another instruction. It is known as compare and swap. The definition of compare and swap is given here. So let's look on to that. Int compare and swap, int star value, int expected, int new value. Open the curly bracket. Int temp equal to star value. If star value equal to expected, star value equal to new value, return temp, close the curly bracket. So this is the mutual exclusion implementation with the compare and swap instruction. Do open the curly bracket while compare and swap and lock 0 1 equal to 0. So this is the critical section. Lock equal to 0, remainder section while it is true. This is the definition of compare and swap. The compare and swap instruction, in contrast to the test and set instruction, operates on three operands. We use three operands here. The operand value is set to new value only if the expression star value equal to expected is true. So it says that if star value equal to expected is true, the operand value is only set to the new value. Compare and swap always returns the original value of the variable value. Like the test and set instruction, compare and swap is executed atomically. They both execute atomically. So this is the next topic we are going to discuss about. It is known as Mutex locks. The hardware-based solution to the critical section problem presented in section are complicated as well as generally inaccessible to application problems. So as we discussed about the critical section problem, sometimes it may be inaccessible to the application programmers. Operating system designers build software tools to solve the critical section problem. The simplest tool of this is Mutex Lock. Okay. As we said here, to the solution of critical section problem, the designers build software tools here. So the simplest tool here it is known as Mutex Locks. We use Mutex Locks to protect critical regions and thus prevent race conditions. That is, a process must acquire the lock before entering a critical section. It releases the lock when it exits the critical section. As we said earlier, this is the point. So these are the two functions used here: acquire function to acquire the lock and release function to release the lock. So it is the definition of acquire function. Acquire while it is available equal to false, close the bracket. If it is available only, it acquires the lock. Next is release function. Release, open the curly bracket, available equal to true. It releases if it is only available equal to true. Okay. So this is the solution to the critical section problem using Mutex Locks. So let's look on to that. Do, open the curly bracket, acquire lock, critical section, release lock, remainder section, while lock. So this is the critical section and this is the remainder section. Okay, on the next slide, it is the main disadvantage of the implementation given here. It is that it requires busy waiting. While a process is in critical condition, any other process that tries to enter its critical section must loop continuously in the call to occur. So this is the advantage of Mutex Lock. Disadvantages of the Mutex Lock. The main disadvantage. It is said that in the process of critical section, any other process tries to enter the critical section must be in a loop to be acquired. In fact, this type of Mutex lock is also called a spin lock because the process spins while waiting for the lock to become available. So it is also known as a spin lock because the process spins while waiting for the lock to become available. As we said, it is in a loop condition. Okay, spin locks do have an advantage. In no context, switch is required when a process must wait on a lock, and a context switch may take considerable time. Thus, when locks are expected to be held for short times, spin locks are useful. So when it is used for when it is held for a short times, we can use spin locks because spin locks are most often employed in multiprocessor systems where a thread can spin on one processor while another thread performs its critical section on another processor. Okay, spin locks also have an advantages. This is the main advantage of the spin lock because spin locks are useful because they often are placed in the multiprocessor systems because they can do two jobs at a time. So when one thread can spin on one processor, the other thread can perform its critical section on another processor. So we have discussed about synchronization hardware and Mutex locks in this video. Hope it's helpful.